Hey, welcome back to Pints and Podcasts here at RavenTek Studio. Today we're going to be diving into all things synthetic data, how it's becoming the ground truth for AI, everything from ISR training models to synthetic drone environments, synthetic modeling environments. And we're going to be diving into it right here with my esteemed guest, Nate Reeves, CEO of SensorOps. Nate is pioneering this industry with what they're doing over at SensorOps, is going to give us some great intel today. And John Vrabel, who's the head of product engineering and customer success for the tactical operational technology business unit at RavenTek. Did I get that right, John?
Yep.
I know I did. That was great. So, gentlemen, thank you. All right. Most important thing, this is where we're going to start. What are you drinking today?
Modelo Especial.
And I understand you liked Modelo before Modelo was cool. Is it cool?
Way before it was cool.
Way before.
Yes.
Like how long? How long have you been drinking?
15 years ago.
15 years.
Yeah.
I don't know if I was old enough to drink back then.
I'm dating myself for sure.
Oh,
but
well.
yeah, it's come a long way. It's now the number one beer. I feel like I should have, a sponsorship or something.
You should. Well, maybe they'll see this and reach out to you, figure out how you can create a synthetic commercial.
Yeah, there you go.
Yeah, I love it.
Yeah, we could partner.
Yeah,
I see it.
that's going to be great. John, what about you?
Same. Modelo.
Same. Modelo.
Yeah.
Love it. All right. Well, I am drinking a Partly Cloudy from Solace Brewery, local Virginia brewery. They have these all up and down the East Coast now, but it's a delicious IPA. I can only have one or two, or this will go off the rails real quick.
Oh, yeah, those things are strong.
All right. Let's kick this off. A little bit of a softball fun question. You thought that was the softball fun question, but it's not. All right. If you could do or train anything in a simulation, even outside of the defense realm, anything, what would it be? What would you want to train in a simulation?
So what sort of a system would I want to train? I would think a humanoid. I'd love to have a humanoid trained. I think that's coming.
Yeah.
Is that where you're going? That sort of a
It's
platform?
it's
like
wide
a
open.
Platform?
Yeah. Or what if anything that you could train in a synthetic environment, Nate?
Yeah, I think there's yeah, I think where we're going with robotics integrated in with just our normal everyday lives is pretty interesting. Obviously we're focused mostly on defense.
Yeah.
And I think that's a massive need, for the country, frankly. But I'm really super interested in where it's also going. Just, like the Star Wars movies are becoming real. We're all going to have some sort of a humanoid here shortly, and I think there's a ton of synthetic training that's going to be needed to make that happen.
Yeah, amen. John?
Yeah, so outside of defense, I think fun would be, let's take it back to softball. I think some sort of mechanism in softball to help kids, girls do better and, see how their strikes are happening in real time and how we can get some feedback in that environment. I think that would be pretty cool.
Yeah, I'm going to get crucified for this, but I'd like to train my wife how to fold my T-shirts.
Oh, no.
So logo out, so I actually know which T-shirt it is when I'm pulling it out of the drawer. But
So for the sake of your marriage, I'm going to make sure the humanoid is trained to do
that's
that.
perfect.
Yeah.
Yeah, that's where we're going to go
So
with
I'll
this.
come right behind
Hopefully
you.
she never said, we may edit that part out.
Yeah.
We'll see.
To
all right.
play off John, I will come and back clean up for you on that one. Make sure.
I'm going to get a stiff forearm to the face for that. So, all right. So let's dive into this, guys. So talking synthetic data, right? So Nate, I assume that if somebody's listening to this, they know what synthetic data is, but let's assume they don't.
Yeah.
Dive into it. What is synthetic data and what isn't it? And, take it from the context of AI training.
Yeah.
Walk us through it.
Yeah. So I think that's probably like a good place to start, because synthetic data, it's a broad category into itself, right? And so we run into this, and a lot of times I'll try and make sure I narrow it and say, like, look, we're doing synthetic imagery or synthetic video, because synthetic as a larger category. Now, so what exactly is it? So at like its root level, it is data that is generated algorithmically, procedurally, in order to mimic real world data. So it's obviously not real world data. It's not fake data, but it is created to mimic what you would see in the real world. Now, that can go anywhere from text-based data, where you're looking for privacy reasons. You want to make sure that it's not people's real financial or health data, right?
Sure.
All the way to X-rays, imagery like we create, right? That's more kind of tactically focused, and videos. So it's pretty broad, but at the end of the day, it's data that's generated algorithmically, procedurally in order to mimic what you would see in the real world.
Yeah. Well, and if we dive into kind of the why, right? So why synthetic data, right? If you look at issues with real world data,
Yeah.
right? Issues around security and cost and risk and, all these things, like, what is it that makes synthetic data so appealing to use for AI training?
Yeah, so privacy can obviously be kind of a constraint with real, in the defense space where we work, classification can as well. So sometimes you've got data that's classified, and folks can't get their hands on it in order to train models. But even stepping outside of that, the real world is complex, and it's infinite. I often get asked, why do I dislike real world data? And I'm like, I don't. Like, if you can get your hands on it, get it. Problem is, you're never going to have enough of it.
Yeah.
And almost by definition, it is a history book, right? It's something that has, by definition, already happened. So if what you're trying to do is anticipate what could happen in the future, then you're going to need another approach. And I think that's where one of the areas where synthetic can play a role.
Yeah.
So I think having a strategy that looks to collect real world data, certainly, but where we can, supplement that with synthetic, allows us to have a better product at the end of the day.
Yeah. So, John, I mean, you spend a lot of time out with the customers that are, looking to SensorOps and other tools and technologies for their synthetic data. There was a point in time where, and I think still today, people are skeptical about synthetic data and the efficacy of what it can be for training AI models. But are you seeing those attitudes shift? Like, what is it like when you go out and talk to customers? Why now? Why are people now so open to the idea of the synthetic imagery data where in the past maybe they haven't been?
Yeah, I mean, I think Nate really hit the nail right on the head there. Like having not the access to data is one of those things that is really kind of driving these conversations. Even some of the partners that we're working with that are doing this regularly with MLOps pipelines, and they have tons of real world data, but they have massive gaps in the data that they're collecting, including their customers that they're building these for. So us being able to come in and augment their existing pipeline, their existing data flows to increase the efficacy of those, is something that we're solving as well. So,
Do you guys, when you're out there talking, do you still see kind of the skepticism of, I don't know, I don't believe it. I don't believe that your synthetic data can be as good as real world data.
Certainly, there's some of that. I think synthetic, as with a lot of kind of novel technologies, got caught up in the hype curve a few years ago, where the kind of anticipation and excitement around what was possible got ahead of the technology.
Yeah.
And because of that, you ended up with some scar tissue. And I think it took a little while to work through the scar tissue. Now, what was always interesting to me, so even a couple of years ago, when I would say skepticism was peaking, if you went and talked to the folks in the AI trenches, right, the data scientists, and you asked them their thoughts about synthetic, their response was always, it has to work. Like, it absolutely has to work. Like, for us to get where we want to go, synthetic has to have a role. And so I think that's where, kind of the Overton window is shifting back towards that being kind of the base case now, where that wasn't maybe a couple of years ago.
Yeah. Well, and with the data scientists that are coming out today, younger and younger, they maybe don't have that scar tissue from the past, as you call it.
That's true as well.
Yeah, they've grown up in synthetic environments.
Yeah.
Right.
Yeah.
So that's a good segue. So talk about that, right? Don't give away the secret sauce, but how's SensorOps creating synthetic data? And, if there's things that differentiate that from what else is out there in the market, what is it? Why is it so good? And I think it ties back a little bit to what we just talked about, but go ahead.
Yeah. So the way that we generate our synthetic data is physics-based 3D rendering at its root. So we provide really kind of the novelty of the approach we took is we want to make a tool where you didn't have to be a data scientist to generate data. And we really kind of created a user interface that is intuitive enough for a non-technical user to go in, pull in the objects they're looking to create classifications for, to be able to customize those objects, to be able to place them into environments, to be able to place their sensors. And then you click build and it goes out and uses an algorithm that we've kind of tuned in-house to manage object placement, sensor placement, varieties in biomes and weather conditions and lighting conditions, all of that based on what we've learned in our own kind of pursuit of computer vision to create a diverse and balanced data set. So it's where we've kind of manually learned what works, what makes a performant model. We've always looked to work backwards and incorporate that into the tool itself. So we're at a place where, we will frequently, when we develop a model, maybe on the fly, for an event the next day, we will see what the false positives are, and we're able to. It is easier for us to generate additional data and quickly retrain a model versus tuning parameters and that sort of thing. So it's faster, it's cheaper, all of that. So we really look to be able to create it to generate the data quickly, but we're not requiring the user to understand how to code, to go in and manually set up each scene. We look to kind of offload a lot of that and really kind of open the aperture on who can create data.
It's done automatically.
Yeah. I mean, the whole idea is get out of being a data collector and be a data designer.
Yeah.
Like, what's the data set you need for your mission? And let's go and create that data set.
What would be really cool is for the folks that actually watch this podcast on video, for our phenomenal producers to overlay this segment with a clip showing how that's done.
Yeah.
I don't know if they're good enough. We'll find out.
To be determined.
They're great. So that, one of the things, and I don't know if I heard you talk about it before, but we always talk with folks about how it's solving the data labeling problem, right? I mean, talk about that a little bit. What is the data labeling problem and how's synthetic data solving that?
Yeah, so essentially a data label is, and we'll use imagery as an example. You're giving the machine an image to train on, and you're then telling it what in that image is important, what of that important aspect, what is the label of the important aspect. So you could have multiple labels in a single image, but then there's also different ways of labeling, and they can satisfy different use cases. So some of it comes down to what kind of computer vision are you trying to make. So there's different label types. So the easiest one to think about and the easiest one for humans, frankly, to do is just bounding box, right? You got an image, you got a dog in there, you put a bounding box around the dog, and now the machine, as it starts to learn, can understand, like, okay, this image, what I'm learning here is that this is what a dog looks like. There's lots of other types of labelings. There's polygon labeling, there's segmentation. A lot of the more complex types of labeling may result in better performing models, but they're far more difficult for humans to label. So from our perspective, we're having the machine label it. The machine knows exactly where it placed all the objects. So we are pixel perfect in something, as complex as object segmentation, which typically a human is not great at. So we're looking to optimize for what makes the model most performant versus some sort of an optimization that's centered around human activity.
Yeah. Give me a John, Nate, I don't care, either of you guys could do this. For the folks that are listening, give us a real world example, right? Give us a real world example of a problem that synthetic data has solved. The customer has brought to you guys and said, we can't do X. Solve it for us as much as you can with the customers you work with. I know some of that information is sensitive, but I think it'd be really cool to hear how synthetic data has solved some real world challenges.
So bring it back to either partners or customers, right? We'll do both, right? From a partner aspect, I talked about data augmentation earlier. So You can have, we did have a partner, without getting into too much detail. There's a very common object out there that you can search Google and find a gazillion images of it. Different angles, different areas. Their model still was not performing well. We came in and supplied them with 2,000 images, increased their model performance by 85% with 2,000 images, right? So that's something that they couldn't do on their own with an entire team of data scientists, right? So that's very powerful from a partner standpoint. Customer standpoint, using something like a small UAS, whether that's in the defense, whether that's in search and rescue, being able to adjust your model in real time and very quickly for the conditions that you're in. You can spend 3 months building a model for a small UAS to fly at a certain altitude and a certain weather pattern. Those things change rapidly. You need to be able to adjust and build a new model very quickly, and that's where we can come in. So if your model starts to fall apart at 1,000 feet, okay, what are we looking like from, going up there? Let's go create a model really quickly and get that out to the edge devices. So
How rapidly can that happen, right? You're in a real world situation, disaster scenario. You suddenly realize the model that you spent 3 months building is failing at 1,000 feet. You've got, SensorOps, for example, in the field. How quickly can you retrain a model?
So from a data generation, I think we can do 10,000 images in a matter of 8 minutes to create create the data, fully annotated data set. Depending on how of a deep model that you want to build. Probably another 30, 40 minutes right there to create a model. Maybe even less, depending on how quick and dirty you want to get it out in the field.
Real time in the field,
Yep.
Operators in the field, not
Real time.
data scientists back in a lab. Super cool.
Correct. Yeah,
Love
and we focus on edge optimized models, right?
Yeah.
So you can run those things on very lightweight compute. You don't need a giant operating system and computer to run these. You can run in something as small as a cell phone.
Yeah.
So
Love it. All right. So we're going to switch gears here for the next segment. Before we do, you love synthetic data.
Always.
I know. Anything you want folks to know about synthetic data we didn't cover?
I think something, ask for a data set, the proof's in the pudding, ask for a data set. Something that I've been kind of challenged with of late is not all synthetic data is created equal. You end up with, we already have synthetic data. Well, let me see your synthetic data. And then you see it and it's like, I can see why you weren't successful. I can see why you think it's not going to work for you.
Yeah.
So, it's kind of the seeing is believing. I do think that we're back in the positive part of the S curve right now. But it's very much driven by use case. It's very much, consistency it's not always the same. It's kind of like we're all drinking beer. We're not drinking, well, John and I guess we're drinking the same beer, but there's differences, and you may end up where certain synthetic data is better in certain conditions and all of that. So I think more than anything, it's get a data set and evaluate it for yourself.
Love it, man. Well, with synthetic data, we all know you can't just build objects. You can build whole worlds, right?
Okay.
And that's what we're going to jump into next. So appreciate it, Nate. John, we're going to jump into synthetic drone training and SynDOJO here shortly. So we're going to take a pause right there. We'll be back. All right. Welcome back. Again, we're here with Nate Reeves, CEO of SensorOps, and John Vrabel, head of product engineering, customer success, tactical operation, technology, business unit at RavenTek. Guys, thanks. All right. So we've really dug into synthetic data, right? You guys have done something really cool. You took synthetic data to the next level. Everybody's heard of digital twins, and you said, we can create real world environments for this. But not only that, we can use them for training. So tell us a little bit, high level, what it is you've created with SynDOJO. And in some ways, I know SynMatrix is in there, maybe not ready for release. Just give us, high level what it is. And then I got a couple questions in here for you about it. And disclaimer, no drones were harmed during the filming of this segment. I say that tongue in cheek, but that's kind of the point, right?
That is 100% the point.
So jump on in.
Yeah. So, so far we've been talking about generating synthetic data for training of machine learning models. Then what we've done on the other side is essentially a mechanism to use essentially the same synthetic platform, but to do it for one, training humans, but then also, the test and evaluation. That's where you're getting into a little bit with what we have coming with SynMatrix, the test and evaluation of AI and autonomy tools, right? So it's really being able to create, high fidelity, photorealistic, scenario-based simulations that can allow humans to team together, allow humans to team with machines, allow machines to team with machines, and really be able to rapidly execute various different mission sets without having to go out in the field, right? Anyone who's working within the defense space is well aware of all of the technical exercises and all of the different activities that are happening quarterly. I mean, you can basically fill your calendar going around with at these events. What we're looking to do is really, bring that to a level where you can train every day. Machines can train 24 hours a day, and really we can bring the level of competency for humans and machines together up to another level. And I think that's super important for what we're doing right now, both from a cost savings perspective as well as how do we train and support the warfighter.
Yeah, which is a perfect segue. Why now? Right? I mean, why now for these synthetic training environments versus live action? Talk about kind of what's driving some of that desire from the DoD to have these synthetic training environments versus just going out and getting real world hands-on experience.
Yeah, certainly cost and time. I mean, if we're going to do all this in the real world, we're just not going to be able to do it fast enough. We're just not going to be able to move fast enough. And I think for us at least, what we saw was, the conflict in Ukraine really was a game changer. I mean, it was a game changer. It has fundamentally changed the way that war will be waged going forward, and it what has occurred over the last couple of years is you've seen time to counter has come way down. It started at 3 months. It's down to, I think the last we had heard was 3 weeks or something. So you've really got to be able to train your forces quickly. You got to be able to do it in environments that are challenging, that maybe you can't duplicate in the real world right now, or at least not easily. So, that's where I think simulation plays a role. And again, the tech at this point is ready. So we're kind of at a good inflection point where the need and the technology have come together.
And we were talking earlier about maybe where in the past simulators for large human controlled devices exist, but at this level, at the drone level, it's just not there, right? It's not. This is brand new.
Yep.
It's a new space. Government doesn't know it yet. Industry doesn't know it yet. Everybody's just starting to get up to speed on what it can do and what the possibilities are.
Yeah, and as the technology is growing, right, you don't need these massive box trainers to do that. You can do it as something as simple as a lightweight gaming laptop where you can take with you. You can train as you're on your way to the mission. You can train as you're on the way to the natural disaster, right, and continue to go through your reps and sets as you're going out. So.
That's a great segue, John. So thanks. It's almost like you teed that up for me. How do you measure success, right? So if you're not doing it in these big box simulators, you're not doing it live with a drone in the sky, how do you measure success and convince the people that this synthetic environment is going to give them the same level of realism that they'll have when they're flying the drone in person, right? Like, I don't know what you've seen on the ground with the guys that are using this, but what are some of those success metrics you could put in place where they know, hey, if I'm flying a drone for the first time and I've had 10 hours of training in a synthetic drone platform, I'm going to be 60%, 80%, 100% more effective than if I was flying it for the first time in a live platform.
Yeah, so back to the notes from the field, like I don't think I could actually put a percentage of like hours to, how much better you would be, but I mean, when I first started flying, I was hitting trees and going all over the place. Now I can do flips and run through buildings and do some pretty cool stuff in the sim. Um, versus if we're at a conference and we have somebody new getting on it for the first time versus an actual professional FPV pilot, they get on it, they're flying. I mean, we had a DoD customer doing one yesterday or the day before. They got on it stick time immediately. We're flying down the hallway, doing, under branches, stuff that I've never even seen, like just floored within 3 minutes of touching the controller. And think about Ukraine, right? They're going through several thousand drones every month that they're just crashing and burning, and they're now requiring their pilots with 200 plus hours of training before they're even allowed to touch a real one. So I mean, this is coming. It's coming fast. So.
Yeah, and I mean, in synthetic environments, 200 plus hours can be a matter of weeks. You're not worried
Yeah.
about weather, right? You don't have to take into the environmental factors that may impact your ability to go out and fly. But you can also train on that in the platform, right? You can train on different. Can you add wind factors, rain factors?
You can add those factors mid scenario.
Yeah.
So you can have an instructor who, feels that you're doing pretty well and tries to make your day a little bit harder by throwing weather conditions at you. So certainly, you can kind of create the as challenging a world as you want to, but then on the flip side of that as well, you can make the world a little bit easier for somebody who's just kind of getting their first few reps in. Obviously, if you're not worried about crashing a $10,000, $20,000, $30,000 drone, you can take some liberties, right? You can try some stuff out. And how do we learn? We learn by trying. So, our whole goal is make your first 10 crashes synthetic crashes, right?
Nate, do you guys have statistics? And if you don't, we'll edit this question out. Do you guys have statistics on how many drones are destroyed in training scenarios and the cost of that to industry on an annual basis? Is that something that's tracked?
I have not been able to find good data. So there's a couple things, right? There's like how many drones are crashed. And now the part of the problem with that data set is like nobody is running around raising their hand. I crashed the drone, right?
Right.
Like that's they're not necessarily trying to make it all that well known, but it's not only about crashing the drone. That's it's also about the wear and tear on the drone, right? So like you drive your car every day. You could get in an accident, and that would be a substantial financial impact. But it's not like driving your car is free. You still have the wear and tear on the car that has to be accommodated. So even if you're not crashing the UAS platform or whatever unmanned system it is, it's still getting the wear and tear. So if you can offload some of that wear and tear, stretch out the life expectancy, then there's cost savings there to be had as well.
Well, then you can practice more advanced TTPs and things that would be riskier to do in the real world, or be able to repeat that over and over again. You can do that in in the simulator. So.
Yeah. And talk about the platforms, right? I mean, there's lots of different drones.
Yeah.
So, how do you guys adapt? How can you train on different types of drone platforms and not just, hey, we do this one really cool drone platform from Lockheed Martin, for instance?
Yeah. So, we support a number of kind of representative drone platforms. So, we go all the way from kind of the nano drones all the way up to, frankly, an MQ-9. So it's and everything in between. So where we typically try to focus is we'll kind of have a generic version of everything. And then as we develop partnerships, our simulators on the DIU Blue List, as we develop partnerships with other vendors who are on the DIU Blue List, will look to create very specific dialed-in versions of their platforms, and we'll make those available as well. So kind of start generic and then get specific as you go. And then everything kind of in between. So we our goal is to expose as much of the configuration to the user as possible. So if you've got, maybe you start with the generic, but you want to change the payload. Well, we allow you to change the payload. Now it's going to fly different because it's heavier, right? So, we want to make it as, we want to put the capability, or the configuration of the capability into the hands of the user wherever we can. So they're not dependent upon us to support their specific use case.
Yeah. So you mentioned the DIU Blue List in there. What is that? What is the DIU Blue List? My understanding is you guys are the only synthetic drone training platform that's DIU Blue List approved. So talk to us about, what does that mean? What is that list? How does that alleviate concerns for both the government and industry,
Yeah.
knowing that, hey, we're an approved platform on this list?
Yeah. So DIU, this is kind of the second iteration of the DIU Blue List. So originally it was just for the platforms themselves. So the Blue List was originally rolled out a few years ago. It was essentially, they down selected a few platforms in each kind of UAS category. What does that mean? DIU puts platforms through some field testing. They select who they feel is best fit for the Blue List, and then they go in and they evaluate the actual platforms. They verify that the parts are coming from where the vendor says the parts are coming from. They verify that the softwares of a certain quality, right, that it can become certified. So they go through this process, and then the whole goal of that is that now the services within the department can acquire those drones or those platforms more quickly, right? So it kind of reduces the paperwork. So it's a bit of a down select and then a facilitation of acquisition. Now, what happened maybe 9 months ago was DIU opened it up. They started to realize, okay, there's more going on here than simply the platforms themselves. If we're going to be successful in the future, we're going to need software as well. So they did a rethink, I believe it was called, and they opened up kind of an RFI, and they allowed software companies to come in and kind of pitch their capabilities. So we pitched our simulator, and we were selected. So we're the only training tool on the Blue List currently, and it's really looking, the end users don't need a single sim for each platform, because a mission is not based on an individual platform. A mission may be a combination of different platforms that all need to be able to collaborate together. So the mission should be centered around the users and the objective versus centered around the platform itself.
Yeah, allow them to train the mission together and not separately for their individual component of that mission.
Exactly.
Yeah, makes sense.
It's interesting you say that, right? Because every time I hear the word sim, like I think of those big boxes, and I'm just going to learn how to fly, and I'm just going to fly and get that down. SynDOJO's significantly more than that, right? And you keep saying mission, we put in the ability for you to build out dynamic mission scenarios, right? So you can run these TTPs, you can build out a mission that you're going on or a mission that you failed at, and be able to do that over and over and get those reps and sets to perfect what you're going to be doing or what you've done. It's not just about learning how to fly and not crash and putting wear and tear on your drone. It's just so much more than that. And we've built it with such high fidelity that the realism that's from the water, it makes it feel like you're really flying in real life, right? And you're not flying in this 8-bit drone simulator that you typically see. So I think that's a big game changer that we're seeing from notes in the field from customers, that there's sims like on Steam that you can get, but they just same thing, right? They allow you to fly, through tires and buildings, and you kind of really get that down, but you don't really get the whole functionality of what you need, and that's why what we've been getting feedback on.
But you guys can also create the real world environment that they're flying through, right?
Yeah.
City, town, you name it, woods, like the actual location.
Yeah. So we kind of think about it two ways. We think about it as representational environments. So That's going to be, it's a woodland environment, but it's not a real woodland environment on the map. Now, the difference there is we control the environment and we can place objects. We have total control. And it's going to be incredibly high fidelity. It's going to be photorealistic, right? That's fantastic for training purposes. Where we've also kind of added capability to the tool is, we're really looking to push more towards mission rehearsal. So mission rehearsal, what we're looking, or the capability we've brought there is an integration where we can bring real 3D tiles into the environment. Now you're able to, place objects, you're able to place platforms, and now you can run scenarios inside of those real world environments. So you can go anywhere on the planet. The data that you get is based off your data source. So if you're the government, you've got certain government data sources. If you're commercial, maybe you're using Black Shark or Google. But you can go anywhere and you can practice the actual mission that you're planning to execute. You can fly through, you can do all that kind of stuff. So it's really using one of our goals is with our use of synthetic or simulation technology is, and this really goes back even to what we're doing with Target Modeler is we look to use simulation technology to create operational capability, right? So we're not looking to build sims for the sake of sims. We're very much looking at how can we use the power of simulation technology, but how can we use it in a way where we are putting a new tool, a new capability in somebody's hands out in the field.
Bringing the mission to you, right? So think of it as train how you fight how you train, right? So we're able to bring in other operational tools like TAC, the tactical operation kit that the government's using, right? So being able to tie that into real time as you're flying, drop in people, drop in cars, so you're tracking it. The warfighters are using it as they are in real world fights, right? So bringing all of those tools in is critical. Right? So.
Yeah, I think that's one of the other areas that we really focus on, and it's very much aligned with that. And we want to integrate with the operational tools. If it's the controller you're going to use in the field, if it's the GCS you're going to use in the field, if it's some sort of AI agent, some sort of autonomy software that you're going to use in the field, that's what we want to integrate with. What we don't want are negative reps. We don't want to train folks on an interface that is specifically a training interface and then put them out operationally using something different, right? Those are negative reps. We want to use the actual tools, the actual software, and we as the sim will meet the controller, will meet the software at its interface. That's our responsibility. And then the operator can be trained on the actual interface that they're going to be using out in the field. So that's kind of something that we very much focus on internally.
Awesome. All right, guys, SynDOJO. What did we not cover? What do you want folks to know about the platform?
Yeah, I mean, we've got the roadmap for SynDOJO, is unbelievable. And I couldn't be more excited about it. I think one of the areas that folks aren't really thinking about yet that I think 12 months from now will seem like, well, duh, right? Is right now the focus very much is on training one human, one unmanned platform, right? 1-to-1. It's like, do I know how to fly this Skydio? Can I fly this Neros FPV, right? Very much 1-to-1. What's being built are, these these swarm capabilities. Like there's a whole software tier that's being built that allows one-to-many, And I think that's the future of training that we're aimed for, is instead of having just, the human operator and their unmanned platform, now we're adding another tier in there. We're adding a software tier. And there's two things that changes. One, that software tier has to be trained against the unmanned platforms. And now the human operator needs to be trained against that software.
Yep.
So it's kind of we're adding a new player, and as we are looking at our roadmap for our platform, we want to be able to support all of that.
Love it. Nate, thanks. John, good?
Good.
All right.
That sounds good.
We're going to have one more session, some rapid fire fun questions, wrap this thing up. But I think before that, we're going to refill these beers because that'll make it a little bit better on this next session. So. All right, we are back. So, guys, thanks. This has been a lot of fun today. I appreciate you guys being here. A couple beers, some good information about synthetic data and drones.
Yeah.
I had a couple fun questions before we wrap this thing up. This goes back to kind of that first question we asked. But what real life skill do you wish that you could learn in a synthetic simulator? Think like Matrix. Pump that skill right into your brain. What would it be?
Man, yeah. I mean, go to the Matrix. There was like some martial arts in there.
Yeah.
Remember
the scene with I need a Apache helicopter program, and it's boom, and all of a sudden she can fly a helicopter.
Yeah.
What would it be?
Don't steal my thunder over there with that karate. That's what I was.
Oh, I know. That's kind of where I was going. Yeah. So where something I could train the brain on. You're an Eagles fan?
I'm a big Eagles fan.
Yeah. Okay. So
Go Birds.
You know how the Redskins? Okay, synthetic data right here.
Yeah.
Okay, so our quarterback actually trains inside of a simulation
At a 2x pace.
At a 2x pace.
Yep.
So, and that built. So now all of a sudden he goes in the real world and everything's slow.
Yeah.
Right.
So you want to train to be the Redskins quarterback?
Definitely not.
Okay.
I've seen what those linemen look like,
Yeah.
and it's hard enough, getting off the couch sometimes. I'm getting old. But I think
John wants trained to be the Eagles quarterback. He likes the tush push.
Anything you can, like, if you can train at 2x speeds, then you can operate faster than everybody else.
But what is it? What does Nate want to learn synthetically?
Want to be a better swimmer?
No. Cycling.
There you go.
Better cyclist. I'd love to, I'd love to spend more time. There's something about cycling that is just like man and machine teaming together that has always interested me.
Sure.
But the idea that you could go into a synthetic environment and you could be anywhere cycling.
Yeah.
Pretty cool.
Love it. It would be cool. It's a little bit different than Peloton, right? Where it's just kind of in front of you. You're there.
I like the snap of the finger. Like snap your finger and you know it. I like that.
Yeah. So there is a Zwift is a platform that is a synthetic environment for cycling, and it's like this could be better. This could be better.
Yeah.
And if I had a whole headset on that wasn't too big, you could just feel like you're totally in that world.
Yeah.
It'd be good.
Love it. John.
To fight and shoot like John Wick. Just get wild. Just
Get
the
wild.
full on.
The John Wick experience in a
Full on.
synthetic environment.
Yeah. Full on slinging
Whole
out
thing.
clips and magazines, just getting wild. Yeah. Just that.
Yeah.
It'll be fun.
I'm basketball. I love basketball. I've always loved basketball. I don't play it as much anymore because I'm old and I get injuries. But to be able to go into a synthetic environment and play not only like I used to, but better, I would love that. Be amazing. Anyway,
Here's to hoping.
Here's to hoping. All right. Sci-fi tech. You could pick one that you could have today. What would it be?
Teleportation, man.
Yeah. Amen. That's my answer.
Yeah.
I'm such a efficiency freak.
Yeah.
To not have to worry about driving.
Yeah.
Just you're there. Amen. What about you, John?
Why are we all the same? As soon as you said that, I thought, beam me up, Scotty.
Beam me up, Scotty.
Just get me up.
Just
Like
get-
that's exactly what I was going for.
That's it.
Yeah.
And my son asks me all the time, Dad, if you could have one superpower, I'm like, teleportation. He's like, really?
Or fly.
I'm like, that's it. That's what I want. Flying. I don't know. Flying still takes time to get places.
Get invisible.
All right, listen, guys, this was a lot of fun. Thank you. We're going to wrap it up. One thing, anything you want folks to know about SensorOps, synthetic data, edge autonomy, synthetic drone training, closing thought.
Yeah, I mean, I think the certainly the battle space, but I would say even just the kind of there's a high focus on the edge right now, and what we're able to achieve from a compute perspective, and I think what we've really been focused on is providing capability, but also providing enabling capability. So I think one of the things that we haven't necessarily talked on is we very much are looking to partner with other AI companies. A lot of what we do, we try and provide an end-to-end solution for customers. We also look to support the rest of the industry and provide our tools as enabling. So I think I would say the future fight is a federated fight. We all need to work together to provide the best capability, and we very much are looking to be kind of good partners in that ecosystem.
Rock and roll. Thank you, Nate. John?
Yeah, second what Nate said, I think that actually probably 2 years ago, and one of the first things Nate said to me is to what he was saying there is SensorOps. Like if you look at a lot of other AI companies, our Venn diagram, like we overlap like a lot of different companies in various spaces, but we tend to work with a lot of other AI companies, and we're supporting them from integration of SynDOJO and doing things like with Breaker and other companies that are giving them platforms to do what they do and do it better, and synthetic data with other AI companies that you could look at us and say, oh, you guys compete at some level, but no, we're here as one and here for the fight. So, and to support the warfighter and whoever else is using our product. So.
Awesome. John, Nate, guys, thanks for indulging me today. This was fun.
Hey, thanks for having me.
Do it again. Until next time on Pints and Podcasts. That's it. Thank you.